Hello everyone. So today let's solve the problem number 1584, minimum cost to connect all the points. So let's see what the question states here. So we are given n points on a 2D plane. Yeah. So we are given n points on a 2D plane. You can clearly see here, right? So in the example one, they have given the graph here, right? So we are given n points on a 2D plane. The cost of connecting 2 points is the Manhattan distance uh, between them. Actually, here you can clearly see the cost of this one connecting 2 points xyi, this one comma yi, and xi comma this one xj comma yj is the Manhattan distance between them. Basically, in simple terms, the cost of connecting between the 2 points is Manhattan distance between them. Actually, Manhattan distance is this one. Yeah, this is fine, I believe. So we must connect all the points so that every pair is reachable with minimum total cost. We must connect what we have to do. We must connect all the points so that every pair is reachable with a minimum total cost. So this is related to the minimum spanning tree. Yeah. So we must connect all the points so that every pair is reachable with minimum total cost and exactly one path between any 2 points and exactly one path between this one path between any 2 points, right? Basically, it forms a minimum spanning tree, right? In simple terms, we need to return the minimum connection cost. We need to return the minimum connection cost. So first here, see, we have been given cost 4. Here we have been given cost 3. Here we have been given cost 9. We have been given cost 4 actually. Yeah, so see here, we can connect the points as shown above to get the minimum cost, right? So from here to here, that's cost 4, here to here, cost 3, cost 4, and from 3 to 10, this is this one, cost 9 actually. Yeah. So one thing, we can connect the points as shown above to get the minimum cost of 20. Notice that there is a unique path between every pair of points. Yeah, there is a unique path between every pair of points, right? So this is fine. Same goes with the example 2 as well. You can just check the same. Yeah, so this is fine. Let's do one thing now. Let's discuss the approach followed by the complexities and then let's write the code as usual, right? As usual, let's discuss the approach first. Just give me a second here. The first thing, so there are many MST algorithms actually we can just make use of. So for this, I'll just be going with a Prim's algorithm. This is one of the famous algorithms, right? So based on the MST basically, minimum spanning tree. So we'll be going with a Prim's algorithm to solve this particular problem, right? So let's see what the first step here. Let's see what is the first step here, right? So we will start from any point. Suppose consider 0 comma 0. So I'll just give me a second here. Let me delete this one. Yeah, let me consider example one itself for the this one, what do you call approach actually, right? So as I've said, we will be going with the Prim's algorithm. Yep. So let's start with the first step here. What I said, first, let's start from any point. Say, suppose 0 comma 0, this one, right? Suppose 0 comma 0, right? Initially, we'll be starting from 0 comma 0 and cost is 0. Initially, cost will be 0, right? Step 2, let's move on with the next step. From 0 comma 0, we will connect the nearest point. So nearest point is 2 comma 2. So this one, let's connect this one, right? So now we have connected this one. Um, Basically, we are connecting the nearest point 2 comma 2. So what is the cost here to connect actually? The cost to connect here is 4, right? So the cost to connect is 4. So we have connected 0 comma 0 to 2 comma 0 here, 2 comma 0, and the cost is 4 here, and the cost is 4, right? So this is fine. So next, what shall we do? From the connected set 0 comma 0 comma 2 comma 2, the next closest one is 5 comma 2 actually. So this one, the next closest point is 5 comma 2, right? So we'll connect this one. Yep, we'll connect this one, right? So now what we will do, I'll just go with 0 comma 0 and 2 comma 0 is set actually. We will connect this one to, we'll connect this set to this one, what do we call 5 comma 2 actually. We'll connect this one to 5 comma 2. So cost will be quite obviously 3. Cost from connecting this set to 5 comma 2 is 3, right? So this is 4 and this is 3 actually. This is 3. This is fine, right? So you can just see 2 to 5, 2, 3, 4, 5. Cost is quite obviously 3, right? So this is fine. Mm, Next, let's go with let's do one thing. From this set actually 0 comma 0, 2 comma 0, and we have 5 comma 2 as well. From this set we will connect the most nearest one. The most nearest one to this particular set is again 7 comma 0, right? So we will connect 7 comma 0. So what will be the cost here? The cost would be 4. The cost would be 4 actually, right? So this is fine, man. The next step would be lastly we connect 3 comma 10. We connect 3 comma 10, right? So I'll just go with here 0 comma 0, 2 comma 0, 5 comma 2, 5 comma 2. This one, the next closest point is 7 comma 0, 7 comma 0 also we have connected. So 7 comma 0, so this one, the last connect this one. Lastly, we connect 3 comma 10. So the only thing that is left here is 3 comma 2. Then we will connect this one to 3 comma 2, right? So 3 comma 2. So this is fine. 4, 3, 4, and we connect this one actually. Sorry, 3 comma 10. Sorry, not 3 comma 2 actually. 3 comma 10. Yep. So this is fine. 1 second. Yep, we'll connect actually 3 comma 10, and the cost is nothing but here we have connected 3 comma 10 respectively, right? So minimum possible edge to 2 comma 2, we'll consider minimum possible edge to 2 comma 2, nothing but cost, it will be 10 actually. Cost will be 10, right? So now we will sum up all the costs actually. So this will be this one is fine. This will be 0 plus 4 plus 3. So this one 0 plus 4 plus cost. Next we got 3. Next we got 4 and 10. We got 4 and 10. So this one will be 4 and this one will be 10 actually. When you sum up this one, 4 plus 3, 7. 7 plus 4, 11. 11 plus 10 is 21. Right? So 11 plus 4, sorry, did I do anything wrong here? Um, Yeah, this one is 21 actually. This one is 21 actually. And this one actually it will be 20 considering this one better connections while building the MST dynamically. So we'll be going with that 20 basically, right? So we'll be going with that 20 basically. Yep. So the output that we got here is 20, which matches the output that we got actually. The output that we got here is 20, which matches the output that they have given for the example one within the question. Sorry. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part here. So this one actually we got 10 here, right? Cost. So this cost is actually 9. It's actually correctly 10 actually. By when constructing that one dynamically, it will be usually 9. So we will go with the 20 rather than the 21, right? So this is fine, I believe. So, yep, let's do one thing. So we got the, now we have the, this one, what do we call? Yeah, and now we know the approach actually completely. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity? So the time complexity would lead to big O of n square, right? So the time complexity would lead to big O of n square, because we will be checking each node. We will be, or we check this one, each node all others to find the smallest edge, or each node checks all others to find the smallest edge here in simple terms. So what will be the space complexity? The space complexity would lead to big of n, right? So why it is big of n here? Because we'll be making use of the arrays to store the MST inclusion and minimum distances. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n respectively, right? So now, as we are completely familiar with the approach as well as the complexities part, we are good to write the code. Let's start writing the code, right? So this is space complexity, not the time complexity. Yep. So this is fine. Yep. So let's do one thing. Initially, let's start with, so as I've said, we'll be going with a Prim's algorithm, right? So first, we need the length of the points actually. Let's assign that one to some variable so that we don't have to write points dot length every time, right? So I'll just go with n equals, So let me copy this one points. Just go with length. Yeah, points dot length. To track if a node is already included in a MST. So let me go with the Boolean. So this is fine in MST equals new. So I'll just go with Boolean of n. Yep, so this is fine. So the next step would be, let's go with a minimum cost to connect each node to MST, right? I'll just go with here int minimum distance. Let me assign this one to new int of n, right? So this is fine. Arrays dot fill of, let me go with dist, minimum dist. So I'll just set this one to integer dot max value actually. Yeah. So this is fine, man. Next, what shall we do? We have set the minimum cost to connect each node to the MST, nothing but the minimum spanning tree. Now, after this step, we have to start with the first point 0, 0, right? So for accordingly with the first example I'm speaking of, we have to start with a first point. Generally, if I want to say, we have to start with a first point actually. So this will be min dist of 0. Let me assign this one to the 0. Yep. So next, we have to store the total minimum cost as well. So this one will be total cost. Let me assign this one to the 0. Yeah. So the next step would be, we need to add all endpoints to the MST, right? So I'll just go with a for loop. So this one will be int I equals 0, I less than n. So let me increment the I. So within the for loop, let me assign u to -1. So this is fine. Let's move on with the first step here. We have to pick the node with the smallest connection cost, right? That is not yet in the MST, right? So let's write the for loop, or let's move on with the iteration part. So this is simple, man. Int v equals 0, vertex v less than n. Let me increment the v. So within the for loop, let me write the simple if condition. Yeah. So this one will be if not of in MST. So let's do one thing. Yeah, let me go with if not of in MST of V actually, and U equals -1, or one more thing, minimum distance of V if it is less than minimum distance of the node U or the vertex U, right? So this one will be minimum distance of the node U. Then we have to set the U to V, right? We have to assign U to V. Let me assign U to V. So this is fine. Let me come out of this one entirely, right? So this is fine. Yep, let's move on with the next step. We have to add this particular node to the MST, right? I'll just go with in MST of U actually. So this one, let me set this one to Boolean value true, right? So the next step is we have to add its connection cost to the total cost, meaning I'll just go with the total cost here. Total cost equals total cost plus minimum distance of minimum distance of U. So this is fine. The final one would be, we have to update all other points minimum distances, right? So I'll just go with the for loop. Int v equals 0, v less than n, v plus plus. Yeah. So within the for loop, what we'll do? Let's go with a simple if condition here. Not of in MST of v actually, in MST of v. So I'll just go with int cost equals math dot absolute of this one. Let's go with actually, we have to go with the points of u0 minus points of v0, and also this one u1 minus v1, right? So these things that we need to do. Just give me a second here. I hope this works. Let's see. I can just write it on this way. Points of u 0 minus points of this one v and 0. Third one here would be less mat dot absolute of points of the same thing. I'll just go with this one. So here instead of u, I'll just go with the sorry, u will be same. Instead of 0, I'll change this one to the 1. And here also, I'll just change this one to 1 actually, v1. Yep. So this is fine. Yep, we are done with this part. Then let's write the simple if condition. If the cost is less than minimum distance of the vertex v, then we will be assigning the minimum distance of the vertex v to the cost, right? So we have to update basically in simple terms. We have to update basically, yeah. So we have to update the cost actually. Cost less than min distance of v, then let me, sorry, then I'll just go with the minimum distance of v. Let me assign this one to the cost. Let me assign this one to the cost. Yeah. So this is fine. Let me format the code once. Yep. So do one thing. Uh, do one thing. We have to return, right? All we have to do here is we have to return the total minimum cost to connect all the points in. So that is stored in the total cost actually. Variable total cost. So let me format the code again and let me hit the submit button directly. I hope this works, man. I have hit the submit button directly actually. We have the error, sorry. Variable, I have misspelled here. This one is minimum dist. Here also, must I have given. Line number 18, right? So let me change this one. 18, 18. Where is 18? Anyways, minimum dist, minimum distance. Yeah. Now let me hit the run button. I should have hit the run button. Anyways, let me hit the run button. So we still have cannot find the symbol. Oh, I have been coding in Python a lot actually. Anyways, let me hit the run button. And so again, I have not misspelled. That has to be small a. Where is it? So yeah, let me change this one to the small a. Now it has to give us the sample test cases has to get passed. No, again, this one has to be minimum distance. Line number 30. So this one I'll just change this one to the n, right? Out of bounds. Hey, so this one, 1 second. If this one, what we are checking actually, 1 second. If out of in MST of vertex v, this is fine, and this is also fine. U equals value -1. So oh yeah, so this one I have done mistake. So here I have to remove this one equals -1 or minimum distance of v less than minimum distance of u. I have to close this one here. Now sample test cases should get passed. Let's see. Yeah, the sample test cases are getting passed, right? So let me hit the submit button now. I hope this, so this one, I hope all the test cases get passed. Yeah, see here, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.